Alright guys, I'm going to show you all of the crazy ways that you can use for loops in Java. Stay to the end of the video so you can tell me in the comment section below how many of these you already knew before watching this video. I can guarantee that there will be at least one new one here. Most people use for loops just for the purpose of iterating over integers. For example, if I wanted to iterate from 0 to 8, I would write it like so. And then if I wanted to iterate in reverse, I would just swap my plus plus operator for a minus minus operator, and then invert my bounds. A lot of people might know that you can actually instantiate two variables if they have the same type in line, like so. So that might lead them to suspect that you can do the same thing with for loops, which you can. So in this example, I instantiate both j and k in the first argument of my for loop. And if I run it, we can see the result here. Our k actually was initialized to 2, and our j was incremented from 1 to 6. But did you know that you can actually have more than one expression in the third argument to your for loop? For example, here, I have both j and k being incremented at every iteration. We can run this to see the result. In fact, it's not only limited to 2 or the number of variables that you instantiated in the first argument. I can even add a third or more if I chose to. For example, here I'll add that j is going to be set to j plus k. Should give us only 2 iterations of this for loop. For loops in Java aren't even only limited to integers. For example, here I can loop over characters. If I wanted to print out all the characters from A to Y, I could do it like so. We can run this to see the result. As expected, we see A to Y. Actually, loops in Java aren't even only limited to primitives. For example, let's make a class here for a node, like for example a node of a linked list. So we'll have a node field, which will be our next, and let's say some data field, like an integer. We can actually create a linked list within the declaration of a for loop. For example, here in the first argument, I'm going to be instantiating my linked list with a first node. And then let's say I wanted to have my linked list only have 9 elements, and the data values should be ascending from 0 to 8. So here my condition is that my current node value data should be less than 9. And then at every iteration of the for loop, I'll first create a new node, and then I'll set the data value of that new node to 1 plus the previous node's data value. And then I'll set the current node pointer to the next node. Now we can actually verify that this works and print out the results with another for loop. But in order to do that, we have to first bring this node declaration into scope. And we also have to ensure that we maintain a pointer to the root of the linked list. So we'll change this to root, move the declaration to here. We'll say that node is equal to our root. And then we will replace these calls to node with calls to root. What we should expect to see here are the integers 0 to 9, which we do. We have a linked list of size. So we successfully made a linked list of size 10 using a for loop. Well, you may have noticed from the last example, the first parameter of a for loop is entirely optional. But actually, all of the parameters to a for loop are entirely optional. This has the same effect as this. Moreover, the first and the third arguments to a for loop don't actually have to contain anything related to instantiating variables or changing or modifying them. In fact, we can have any expression in the first and the third arguments to a for loop, or any number of those expressions. For example, here I just print some values within the first body of the for loop, or first argument of the for loop, which will happen first, and then at every iteration, I just print out values as well here, C and D. We can run this to see that we should get A, B, C, D, C, D, which we do. Now we're going to get a little wacky. Now it's going to get a little crazy. So let's say we have some data structure that we want to modify, or that's just one particular example, but let's say we have some process we want to complete. In my example here, it's going to be like populating an array list. Let's also say that for the sake of argument, our array list has some condition as to what values it should be populated with. So for example, I want my array list to be of size 10, and according to some condition, I only want integers that fit that condition to exist within that array list. We can add a simple condition here, like for example, that our values in the array list should only be odd numbers. Now, it's not really like, again, that's a simple example that we don't need to write so verbosely, but you can have any complex condition here. Maybe it has to do with other logic, with other processes running, or other logical workflows going on in your program. But for the sake of this example, we just have like a simple condition that we want only odd numbers in our list. So one way to do that, or the simple way to do that, would be to just write a for loop that loops from 0 to whatever the size is that we want our list to be, and add integers that are odd numbers to that list. We can print out this list to verify that it works. And we see here we have 1, 3, 5, 7, 9. We have only odd numbers in this list. But what if, for no reason at all, we wanted to actually just do this all within the declaration of a for loop? We can do that by first setting a bound like last time. Let's say we want the list size to be less than 10, so we only want 10 elements in our list. Then we're going to make an anonymous class by abusing the fact that we can implement the methods of an interface in line. So for example, let's use the runnable interface. Of course, we're not going to use the multi-threading capabilities of it, and we're not going to like put it into a thread, but we can just use the interface like so. The runnable interface requires us to write the method, the run method. There we go. And in our run method, we can actually house the logic that adds values to our list. So we'll say first, like if we don't satisfy our condition, then we will return. And otherwise, we can add to our list. In order to keep track of how far we are iterating, we can abuse the fact that static variables persist over all the instances of a particular class, even for anonymous classes. So we'll add a static integer here, and we'll set it to -1. And then we'll increment at every conditional check here. And then, at every iteration of the for loop, what we're going to do is take this anonymous class and call the method that we just implemented. And finally, I'm going to print out the value of our list to see, so that we can take a look at the results. And look at that, we have the correct result. We have 10 elements in our list, and they're all satisfying our condition. In this case, obviously being that they're all odd. Now you might be wondering, well, why didn't I use an anonymous class with a lambda expression? And the reason for that is because we needed to utilize this static variable. I want to give a little disclaimer here just to point out that I'm not suggesting that you write your code this way. This is actually, for the most part, completely unreadable. But I just thought it would be a little funny to explore all the ways that you can kind of abuse the syntax of the for loops in Java. Comment down below to let me know how many of these you guys actually knew, because if you guys knew all of these already, then I'm going to need to step it up a little bit and show you guys some even more esoteric things about Java, because although Java gets a little slack for being boring, there's actually a lot of interesting little things about it that I could cover in future videos. So again, don't forget to like and subscribe if you're new to the channel, and I'll see you in the next video. Peace.